All right, finishing off the note from 6.5 on applications of parabolas using either standard form or vertex form. We looked at part A already. So given this equation where X is the number of items made in some kind of a manufacturing process and C is the cost per item, question A says how many items should be made in order to minimize the cost. How do we know that our answer is a minimum? Well, we talked about how we know it's a minimum because if the parabola opens up, then our cost should have a minimum value rather than a maximum. And we did that by taking our standard form equation and working with it to complete the square and turn it into vertex form equation. So standard form, vertex form. And from vertex form, we know where the vertex is. Thus, we know what the actual cost is for the minimum cost per item, and we know how many items we have to make to give us that cost. Nice little economics application. So part A, once you complete the square, we figure out that a minimum cost of $200 per item occurs when the manufacturing process makes 100 of them. So it would actually, if we made 110 items, it would actually cost more. Or if we made 90 items, it would actually cost more than $200 per item. Now, same question, part B. Let me just take the equation with us. And there we go. Part B. If the cost per item needs to be lower than $400, how many items should be made? Well, if we need to know the cost per item, if the cost per item has to be lower than 400, let's actually find out how many items need to be made so that the cost per item is 400. Because if we know how much it's going to cost to be $400, then we know the number of items that needs to be made, so we know how many items should be made in order to have lower cost than that. So 400, so I'm looking for how many items give me a total cost of $400 per item. So 0.1, I like fractions. 1/10 x squared minus 20x plus 1200. Move the 400 over, or however you want to think of that. So 1/10 x squared minus 20x. 1200 minus 400 is plus 800. Now, I don't like fractions, neither do you guys, so let's get everything into whole numbers. And if you remember way back when, the way we can deal with a denominator is, rather than having 1/10, well, let's multiply this term by 10, or in other words, multiply every term by 10, and that'll get rid of this denominator. However, if I multiply this term by 10 to give me 1x squared, I have to do it to everything. So this becomes not 20, but 200x. And this, rather than 800, it becomes 1,000. 8,000. Sorry, not 1,000. 8,000. And luckily, 0 times 10 is 0. Okay, solve for x. Well, there's two things I can do. I can either determine whether or not this is factorable, or I can just jump right to the quadratic equation because I don't want to deal with this. So let's do that because that might be what you would do. So negative b, so this becomes positive 200, plus or minus the square root of negative 200 squared minus 4 times a, which is 1, and c, which is 8,000. This is going to be a big number. All divided by 2a. And because I don't want to do all that in my head, I'm going to go to my calculator. So 200 squared, or negative 200 squared, minus 4 times 1 times 8,000 is, hey, 8,000. Cool. And the square root of 8,000, so let's just see if that actually is a nice number. Square root of 8,000 is not a nice number. So 200 plus or minus the square root of 8,000 divided by 2. So one of my answers is going to be 200 plus square root 8,000 divided by 2. Make sure you watch your keystrokes so that you don't go 200 plus square root of 8,000 divided by 2. Your calculator won't read that correctly, or the way you intend it to. So 144 items, okay, because we can't make 0.7 of an item, so let's just say 144 items, or the other value is 200 minus the square root of 8,000 divided by 2, 55.2. So let's say 55. Now, graphically, so we have to interpret this because we got two valid answers here. Okay? We know that the cost of this manufacturing process looks something like this, right? Well, if I make 55 items, my cost is going to be $400 per item. If I make 144 items, then my cost is going to be $400 per item. Well, rather, what is it? 55.2 and 144.7 and 55.2. So if I'm going to have a cost that is lower than $400 per item, I need to be in between here. So my x values, so a number that's, so 55.2, I can't make 0.2 of an item. So if I go to 55 items, I'm actually going to have a higher cost. So I need to go, so yeah, if I go to 55 items, I have a lower cost, or a higher cost. So I need to go to the next number after that. So 56 items will put me at a lower cost. And rather than 144.7, I'm going to round this way, so I'll go to 144. So these are my two values that answer how many items should be made. Therefore, between 56 and 144 items should be made. Now, if I compare that to my answer for number one, hopefully this makes sense. It costs $400 per item between 56 and 144. The lowest cost, rather than $400, it's actually a minimum of $200, which is by cost cut of half. Half is expensive at $200 per item, and that occurs at 100 items, which is nicely between these two numbers. So I know that my answer is somewhat reasonable. Okay? So that's how you do part B, and we'll do another video on how to do part C.